Hello everyone, welcome back to my channel, and in this video lecture we are going to discuss about the clustering and K-mean clustering. So what is clustering? Means grouping the elements, same type of element into one group or different groups. So what is K-mean clustering? K-mean clustering is an unsupervised machine learning algorithm used to group unlabeled data into clusters based on similarity. The algorithm aims to partition the data set into K clusters, means number of groups, K equals to 2, 3, number of groups we want to create, where each data points belong to the cluster with the nearest mean, saying as the cluster centroid. Means if we want to create two groups, and we will take two elements from the data set, and by one we finding the distance of each data points from that two centroids, and the nearest distance centroid we assign the data point into that centroid. So this particular definition, or what I said, is understand by you by an example. But first we understand the that how k-mean clustering works. So the algorithm of the k-mean clustering is, first is initialization. Randomly select k points as initial centers. Means how many groups we want to create. Suppose we want to create three groups, so हम k की value 3 रख देंगे. We want to create four groups, so we will take 4 as a k. So second is assignment. Assign each data point to the nearest centroids based on the Euclidean distance. So now we will, if we select how many groups we want to create. Suppose we take k equals to 2. And we also take initialize C1 and C2, means centroid 1 and centroid 2. Then we assign each data point to their centroid 1 and centroid 2 according to their nearest distance. Then updation. Recalculate the centroid as the mean of all data points assigned to each cluster. Then we will get the cluster after assigning each data point to their cluster. And then after we calculate the mean. And after calculating the mean, again we decide that mean as a cluster, new cluster. Then iteration. Repeat the assignment and update steps until the centroids no longer change or maximum number of iteration is reached. अब वे हम यही प्रोसेस बार बार रिपीट करते रहेंगे, और तब तक रिपीट करेंगे जब तक हमें प्रीवियस और करंट मीन या प्रीवियस और करंट जो सेंट्रोइड्स जो सेम ना आते हैं. तो जब तक ये दोनों सेम आ जाएंगे हम वहीं स्टॉप हो जाएंगे, एंड द फाइनल क्लस्टर्स आर अवर आउटपुट. Now we will understand this by an example. Suppose we have a data set from 1 to 10, and we want to create two groups. So here k equals to 2. So round 1 is initialization. So firstly, initialize two centroids. For example, we take C1 equals to 5 and C2 equals to 10. Assign the data to the nearest centroid. Now we will find the distance of data points to the centroids, and nearest distance point will be assigned to their centroids. So for example, we take 1. If 1 minus 4 is 1 minus 5 is 4, and 1 minus 10 is 9. So 4 is smaller than 9. So we will assign 1 to C1 cluster. Now to second point. So 5 minus 2 is 3, and 10 minus 2 is 8. So here uh, 3 is greater than 8. So we assign 2 into cluster 1. Similarly with 3, 4, 5 and 6, 7, we assign these data points into cluster 1. And when we minus 8 minus 5, we get 3. And when we minus 10 to 8, we get 2. So here 2 is assigned to cluster 2, and similarly 9 and 10 assigned to cluster 2. Now we will, sorry, now we will find the mean of this cluster. So cluster 1 mean is 4 and cluster 2 mean is 9. Now these two mean again become centroids. C1 is 4 and C2 is 9. Again we will do a same step. So here we will find the distance of data points from these two centroids and assign them according their nearest distance. So here 1, 2, 3, 4, 5, 6 have nearest distance with 4, neither 9, and 7, 8, 9, 10 have nearest distance with 9, not with 4. So the mean of this cluster 1 mean हमारा क्या हो जाएगा 3.5, and cluster 2 का mean हमारा हो जाएगा 8.5. तो हम यहाँ पे ले लेंगे approx which is 3 and approx of 8.5 which is we 8. So now हम again C1 की value 3 रख देंगे, C2 की value 9 रख देंगे. So we will get output 1, 2, 3, 4, 5 in C1 and 6, 7, 8, 9, 10 in C2. And the mean of C1 is 3 and mean of C2 is 8. Now you can see that if we get 3 and 8 as mean of cluster 1 and cluster 2 respectively. So again the C1 and C2 will be 3 and 2, 3 and 8, I'm sorry. So here we get same C1 and C2 from previous clustering. You can see that here C1 and 3 and C2 is 9. I'm sorry, एक mistake हो गई. So by mistake, I wrote C2 equals to 9, which is not right. C2 equals to 8 is right. So here you can see that C1 equals to 3 and C2 equals to 8. And again, we get C1 equals to 3 and C2 equals to 8. So here we get same C1 and C2 from previous clustering output. Therefore, our algorithm stops here and the final output is cluster 1 equals to 2, 1, 3, 4, 5 and cluster 2 equals to 6, 7, 8, 9, 10. So practical applications. K-mean clustering is widely used in various fields such as customer segmentation, image compression, and anomaly detection. In customer segmentation, grouping customer based on purchasing behavior to tailor marketing strategies. Means when companies want to sell their products more according to the customer behavior, they perform K-mean clustering algorithm on basis of the quantity of the product buying by the purchasers and how many products which are less in price are buying by the purchaser and quality of the product are buying by the purchaser, which flavors is most sell in the previous months or year is find according to K-mean algorithm, and they set their goals to produce more products. And in anomaly detection, we here simply find that how K-mean clustering algorithm used to classify or cluster the data points. So here, if the data point is not matching with any cluster, then similarly it is an unusual. So it's an unusual data. So identifying unusual data points that do not fit into any cluster is called anomaly detection and which easily find by the K-mean clustering algorithm. So limitations of K-mean clustering algorithm is while K-mean is a powerful clustering algorithm, it has some limitations. First is sensitivity to initialization. Different initial centroids can lead to different clusters. Assume spherical clusters works best when clusters are spherical and equally sized. It works only on spherical clusters, not suitable for non-convex clusters, struggles with cluster of arbitrary shapes. So in conclusion, we can say that K-means clustering is a versatile and widely used algorithm for grouping unlabeled data into meaningful clusters. By understanding its working, implementation, and applications, you can leverage its power for various data analysis tasks. Thank you. Thanks for watching this video.